Hello everyone, today we'll be looking at questions 21 to 31 of the Maths Advanced paper for 2020. So overall this section wasn't too bad, but there were a few questions that stumped a lot of students, and we're going to take a look at all the questions that we see. So we start off with question 21, and it says hot tea is poured into a cup. The temperature of tea can be modeled by this equation, where T is the temperature of the tea in degrees Celsius and T minutes after it is poured. What's the temperature of the tea 4 minutes after it has poured? So what we do here is, it's pretty simple. We're going to sub in for little t, we're going to sub in 4 minutes. So we've got t equals 25 plus 70 outside of 1.5 to the power of negative 0.4 times 4 for the 4 minutes. And we sub that in, and we arrive at our answer, which just plugging it into the calculator. So that will be 61.6 degrees Celsius if we're rounding it to one decimal place. Part B, at what rate is the tea cooling after 4 minutes, 4 minutes after it has been poured? So what we're going to do here, because it's asking for the rate, we're going to be deriving. So we derive capital T, our temperature, with respect to little t, our time, and essentially the 25 goes away, and this 70 outside of 1.5 to the minus 0.4 t, that's an exponential. And so this negative 0.4 is a very important part of that exponential because it's next to the t, which is what we're deriving with respect to. And so what it's going to be is it's going to be 70 outside of 1.5 to the negative 0.4 t, which is just what we started with originally. And then out the front, we multiply that by minus 0.4, which was the exponential next to the t, multiplied by the log of the base, which is ln of 1.5. And then we can clean this up, but if we just, skip a few steps and just assume at t equals 4, which is what the question's asking, we get a rate, and we plug all that in. Whenever we see little t, we're going to be plugging in 4, and what we get is minus 5.9. So we can conclude that at t equals 4, so after 4 minutes, t is cooling at a rate of 5.9 degrees Celsius per minute. And that's because the temperature is in degrees Celsius and the time is in minutes. So then if we just look at the final question here, it says, how long after the tea is poured will it take for the temperature to reach 55 degrees? And that's essentially saying, if we sub in big T for 55, what is little t? And so then we just say 55 equals 25 plus 70 outside of 1.5 to the minus 0.4 t. And I'll just take you through this one. So we subtract 25 from 55 and we arrive at 30 equals 70 outside of 1.5 to the minus 0.4 t. Divide 30 by 70, we get 3 on 7. And that equals 1.5 to the minus 0.4 t. Take the log of both sides, so you get log of 3 over 7, equals, now when you log an exponential like this, you can bring the power down to the front. So minus 0.4 t times log of 1.5, as you can see there. And from here, we just want to solve for t. So that means we take it on its own, and we have log of 3 over 7, all divided by 0.4 ln 0.5, sorry, ln 1.5, and sorry, that's negative as well, negative 0.4, and then we arrive at the answer, which is approximately 5.2 minutes. Now you can put this answer in seconds, but considering, t, where we're considering just as minutes, we can just apply a decimal place here and just say 5.2 minutes. So the next question we look at, question 22, says the diagram shows a rectangular decagon, which is a 10-sided shape with all sides equal and interior angles equal. And it has this center O here. So the perimeter of the shape is 80, and they say by considering this triangle here, calculate the area of the 10-side shape. And give your answer in square centimeters, correct to 1 decimal place. That's very important too. So first, we need to understand, well, if we calculate the area of the triangle, we've got 10 triangles here, right? So if I multiply it then by 10, then I'm going to get the area of the whole shape, okay? So to find the area of the triangle, if you think about it, we can do, traditionally, you can go half base times height, but that's not so easy in this instance. So we're going to need to use some sort of trigonometry. And if you remember, the area of a triangle can also be half times A times B times sine of C, where A and B are going to be these two lengths there, and capital C, the angle, is going to be that the one coming from the center. So this question's a little bit involved. I think first we're going to find the length, find the angle C. And so if you have a regular shape, the sum of the interior angles is 360 degrees. So if I take 360 degrees and divide it by 10, because I'm going to have 10 of those angles here and all 10 of them are equal, then we just get 36 degrees, right? So this angle here, C, is 36 degrees. Now then, we just need to find A and B. And if you notice that these are equal, it means A equals B. So they're going to be the same length. But we need to try and find that, and that's going to be through the 80 centimeters there. And so if they're saying that the perimeter is 80 centimeters, we can't exactly find A and B directly, but we can find this length here from A to B. And pretty simple, we can say length AB is going to be 80 divided by 10, which is 8 centimeters. And the reason why we can say that is because they tell us that this 10-sided shape has all sides equal, right? So if we take 10 sides, take the total perimeter and divide it like we did, we're going to arrive at the length of one of those sides. Now, to find A and B, if I just quickly draw another triangle here. So this is going to be our A, this is going to be our B. These are our equal angles that we want to try and find. And this here is our angle C, which we found out to be 36 degrees. This is an isosceles triangle, and what we should know about isosceles triangles is that the base angles are equal. And if the base angles are equal, we can say, well, since we know that the total sum of interior angles in a triangle is 180 degrees, then we can say these angles here, right? So let's call it, let's say that's O. So we can say angle OAB equals angle OBA, which equals 180 minus 36, all divided by 2. And the reason why we divide it by 2 is because if we take the 180 minus the 36, we have the remainder of these two angles. And because they're the exact same, if we halve it, then we're going to get at our answer. And what we end up getting is 72 degrees. Okay? So now that we know that, we can find this A and B here, which we can just call R, because it's sort of like the radius of the shape. So if we try and find the radius, we're going to need to use the sine rule. And so I'm going to go over here and say, well, R over sine 72 is equal to this length here, which we determined was 8, over sine 36. Now, what we can do then to find R is just multiply sine 72 over, so we get 8 on sine 36 times sine 72. Just going to focus up here. And then once we get that, we can figure out what r is going to be, which we can just approximate as 12.944. And then when you put that, when you achieve that answer in your calculator, I would recommend storing that answer. And then you can calculate the area to be, so the area of one triangle is half times A times B, which is R times R. So I can just say 12.944 squared times sine C, which is sine of 36 degrees, right? And we get about 49.24 centimeters squared. So that means if we want to find the area of the entire shape, so the shape area, we just multiply this by 10 because remember there's 10 triangles. And then that's 492.4 centimeters squared. And remember, it's going to be to one decimal place and in centimeters squared. Moving on to question 23 here. We've got a continuous random variable, x, has the following distribution. And it's saying it follows sine x from 0 to some number k, and then it's 0 for all other values of x. First question says find the value of k. So if we know that this is a continuous distribution and it's a PDF, a probability density function, then we can assume that if I integrate across my whole bound, so from 0 to k of that PDF, then I'm going to get 1. And that's because if you take the probability of everything that was to occur, well, the chance of anything occurring is going to be 100%. So that's why we say it's equal to 1. So how do we integrate sine x? That should be pretty simple. That's going to be negative cos x from 0 to k, and that equals 1. Plug this in, we get negative cos k minus cos 0 equals 1. Now if we think about cos 0, that's equal to 1. So negative cos k, sorry, this should be a plus here because we go minus minus. So plus 1 equals 1. And then we have cos k can be equal to 0. And now if we try and figure out, what the angle, or what the degree is, or what the angle is when the cos curve is equal to 0, well, that's going to be equal to 90 degrees. But we should have answers in radians, so that equals pi on 2. Okay? Now find the probability of x that is less than or equal to 1. And we need to correct our answer to 4 decimal places. So to do this, the probability that x is less than or equal to 1 is just saying what's the probability that x is between 0 and 1, because remember our lower bound is at 0. And so then we just need to integrate from 0 to 1 of sine x dx. And I'm not going to go through the specifics of that because it's very similar to what we've done up there, but make sure that your answer is in radians. So when you put this in your calculator, make sure you're not putting in 1 degree, but instead you're putting in 1 radian. And so your answer should be 0.4597, okay? So make sure it's in radians. Can't stress that enough. Next question, 24, says we have a circle here that's reflected in the x-axis. And they're saying sketch the reflected circle showing the coordinates of the center and the radius. So the first thing that we need to do here is actually find out what is the actual circle we're looking at, and then we're going to be reflecting that. So the first thing that you should do is you should be able to complete the square in order to find what our center is and what our radius is. So let's just start with the equation. X squared minus 6x plus y squared plus 4y minus 3 equals 0. Now, if you like, you can kind of put brackets around these because we're going to complete the square for each of those brackets. So x squared minus 6x. Now, how do we complete the square? So we take just the x, okay, and we subtract 3. Now, the reason why we get 3 is because we take half of the 6, and then minus follows the minus. Square that, and then you subtract the square of this number. So we're subtracting by 3 squared, which is minus 9. Okay? Then we've got this plus, and now we're going to complete the square for y squared plus 4y. So using the same process that we did, it's going to be just the singular y, not y squared or anything, it's just y, plus half of what this number is, so half of 4, which is 2, close bracket, all squared, subtract the square of the number inside, so subtracting the square of 2, which is 4, and then we have this minus 3 left over, and that all equals 0. And then we're going to get x minus 3 squared plus y plus 2 squared minus, now if we minus 9, minus 4, minus 3, we're going to get 16, which we can just say then is x minus 3 squared plus y plus 2 squared equals 16. Now, using our knowledge of circles, we should know this is a circle with center 3, negative 2, and radius 4. Okay? So 3, negative 2, that's going to be because we take like the opposite sign of kind of what's in the bracket. So if it's minus 3 here, you take positive 3, and if it's plus 2 there, you're taking negative 2 for the y coordinate. So that means when we reflect the circle, now it's important to note that we're reflecting this in the x-axis, which means if you have an original circle like this, we're reflecting it like that. Okay, so that's our reflection there, because this is the x-axis, which means that the x-coordinate, which is the 3 here, stays the same, but the y-coordinate is what's changing. So the reflected circle has center 3, positive 2, and radius 4. Right? So then, pretty simple. From here, to be able to graph it, we're just going to do a rough sketch here. So that's my x-axis, it's my y-axis. X is about 3 there, y is about 2 here. So we're going to have our circle there. Now do keep in mind where your circle is going to cross the axis, or if it's not going to cross the axis. So because our radius is 4, then it's going to be kind of our left edge is going to be at minus 1 because we take 3 minus 4. And then our right edge is going to be at about 7. Well, not about, but it's going to be exactly 7, which is about here. And that's because 3 plus 4 gets you 7. And then you can do the same thing up here. So it's going to go up at 6, because 2 plus 4 is 6. And if you go down by a radius of 4, we arrive at minus 2. And that is going to be around there. So let's just kind of do a rough sketch. It's not going to look like the best circle here, but you get the point. Okay? One thing you do need to note is that you need to show the coordinates of the center and the radius. So maybe put a line here and say r equals 4, and then just here put c 3, 2. Right? And that should be enough. Next question here is we've got a gardener that wants to build a garden bed in this sort of shape here. So this is a quarter circle here, and we've got a rectangle with dimensions x and y. The garden bed is required to have an area of 36 meters squared. So the total area here needs to be 36 meters squared, and a perimeter which is as small as possible. Let p meters be the perimeter of the garden bed, and we need to show that p is given by this expression. So the most important thing to note and how to approach these sorts of problems is that when we need to find our perimeter, what unit is it given in? And it's only given in x, right? Which means what we need to do is find an equation for y in terms of x. So if I can say y equals something, and that something is in terms of x, then I'm pretty close to trying to find the perimeter. So we need to use the information that they've given us, and the only real information is that the area needs to be 36 meters squared. So if I consider the area and the formula for the area, that's going to be the area of the rectangle, which is x times y, which I just say is xy, plus the area for the quarter circle. Now, if you think about the area of a full circle, it's pi r squared, where these lines here are our radius. And if you notice, x is going to be our radius because this is an edge of a rectangle. So the area of the circle is going to be pi x squared, but it's not a full circle, it's a quarter circle. So we take a quarter of pi x squared. Now we then know that the area is going to be equal to 36. So all we need to do is just plug in 36 for our area, like so. And then all we need to do is get y in terms of x. So I can say then xy equals 36 minus a quarter pi x squared. And then if I divide by x, I get y equals 36 on x minus a quarter pi x. Now it's very important when we divide by x here, x could, x can be 0. So we got to keep in mind that in general algebra, when we do something like this, we can't always divide by x because x might be 0 and you can't divide by 0. But because we know x is a length, all lengths must be greater than 0. So that means we're allowed to divide by x in this instance. So that means we got our expression for y, and now we need to actually find the perimeter. So if we just have a general expression for the perimeter, capital P, that's going to be equal to, well, it's going to be equal to 2y because of the, because of the rectangle, plus 2x, because we've got an x here and an x here, plus, sorry, my bad, plus 2x because we've got an x here and an x here, right? Because this length here does not make part of the perimeter. And then plus this curved edge here. And if you remember, the circumference of a circle is 2 pi r, which is 2 pi x, but we've got a quarter circle, so we take a quarter of that, right? And then if we just do a little bit of simplifying here, we've got 2y plus 2x plus, so a quarter of 2x, that's going to be a half pi x. And then we substitute y for what we found out previously. And so that means we're going to get 2 outside of 36 on x minus 1/4 pi x plus 2x plus half pi x. And that equals 72 on x, which now we're starting to see some resemblances, minus 2 times a quarter is a half pi x plus 2x plus half pi x. These half pi x's are going to cancel themselves out, bang, bang, and we get 2x plus 72 on x, which is what we were required to find. Now the final part to this question says, find the smallest possible perimeter of the garden bed, showing why it's the minimum perimeter. So to find the smallest perimeter, we need to find the value of x, which minimizes p, and that's going to be done through deriving it. So deriving that equation that we determined. So p equals 2x plus 72 over x. We've got to derive that. And to show why it's the minimum perimeter, we're going to be we need to show that it's a minimum at that point. So that's going to require us to use maybe the second derivative or use the first derivative and show like a change in signs. So our first step is going to be dp dx. So we're going to derive our perimeter with respect to x. And that, if you think about it, is, so 2x just goes to 2. Now 72 over x is 72x to the negative 1, just like that. And so if I derive this, it's going to be minus, because I put the minus 1 in front, minus 72 over x squared. And that's because you're subtracting the power by 1, and minus 1 goes to minus 2. And x to the power of minus 2 is the same as x, like dividing by x squared. And then we need to set dp dx to be equal to 0. So dp dx, so let dp dx equals 0, and that means 0 equals 2 minus 72 on x squared. And then we get 72 on x squared equals 2, x squared equals 36, and that means x equals plus or minus 6. If x is equal to plus or minus 6, we should know that x is a length, but x is a length and then is greater than 0. Therefore, x is equal to positive 6. So that's the value of x which minimizes the perimeter, but we need to show that it's going to be the minimum perimeter. And the way to do that is we can derive this again. So using similar rules to what we used when we derived 72 on x, if we derive negative 72 on x squared, so if I get d squared p on dx squared, so that's the second derivative of p with respect to x, we're going to get 144 on x cubed, and then at x equals 6, it's equal to 144 on 6 cubes. Now we don't really care about what the value of 144 on 6 cubed is. All we really care about is if it's going to be positive or negative. And 144 on 6 cubed is obviously going to be greater than 0, so positive. So therefore, minimum at x equals 6. But that's not the question. The question isn't to find the value of x which minimizes the perimeter. It's just it's to find the perimeter that is the minimum. So that means the minimum perimeter is when x is at its minimum. So that's it. That means we plug in x. We plug in 6 for x. So it equals 2 times 6 plus 72 on 6. And then that is just equal to 24 meters. Okay, so question 26. We've got some sort of inheritance. So Tina inherits 60,000 and invests it into an account that earns a rate of 0.5% per month. So that's very important when we discuss finance-related questions. So per month is her interest rate. Each month immediately after interest is paid, so once the interest is paid, she withdraws $800. The amount in the account immediately after the nth withdrawal can be determined by using this recurrence relation. And we know that n is from 1 to infinity, and A0 is equal to 60,000. So n is not, from 1 to infinity, it's just however many n's it takes to get her balance to 0. Now use the recurrence to find the amount of money in the account immediately after the third withdrawal. So A3, which is the amount in the account immediately after the third withdrawal, is equal to AN minus 1, which is A2, times 1.005 minus 800. Okay, and now in order to find this, we need A2. And if you think about it, to find A2, we need A1. And to find A1, we need A0, which we have. So let's just work from the ground up then. So instead of going A3 equals this, let's start with A0 and build up to A3. So A0 we know is 60,000. A1 is equal to A0. Now I'm not going to write the full thing. I'm just going to say it's 60,000 times 1.005 minus 800. And that's just going to be equal to 59,500. A2 is then equal to A1, which is 59,500, times 1.005 minus 800, which is equal to 58,997.50. And then A3 is equal to 58 997.5 times 1.005 minus 800, which is just equal to 58,492.49. Okay, simple as that. Now, part B says calculate the amount of interest earned in the first 3 months. This question can be difficult for some people who might not understand what to do. But if you think about it, interest is just the amount that's earned more than what you kind of began with. So if we're sort of making all these constant withdrawals, the reason why it makes it hard is because we're making those constant withdrawals. So if we're making them, then let's just assume that there was no interest paid. What is the amount that's left over if there's no interest? So no interest after 3 withdrawals. Well, we start with 60,000 minus 800 per withdrawal. So 3 withdrawals, we subtract 800 by 3. And so then if we calculate that, so 8 times 3 is 2,400. So if you take the 60,000 minus 2,400, we're just going to get 57,600. Okay? But that's not the amount that we end up with. If you think about the amount that we actually ended up with, it was 58,492.49 cents. So the interest is then the 58,492.49 minus the 57,600. And the reason why is because we ended up with more than if we were to just have no interest. So the amount extra that we accumulated is just all the interest that has been put into our account. And if we calculate that, we get 892.49. Okay. The next question is pretty simple if you're exposed to these types of questions. It's not too intense, but it says calculate the amount of money in the account immediately after the 94th withdrawal. So what this requires is some recurrence relation to be built. And if we start with saying A1 is equal to 60,000, 1.005 minus 800, right? Then that means A2 is going to be equal to, well, it's equal to A1, which is the 60,000, 1.005 minus 800 times 1.005 minus 800, right? Because we've got the A1 times the 1.005 minus the 800, because that's what we're following in this annuity, in this recurrence relation. So getting back to the actual question here, if we kind of don't calculate what it is, but if we sort of collect like terms a little bit, we're going to get 60,000 times 1.005 squared minus 800 outside of 1.005 minus 800. Okay. Now, if I keep doing this, I'm going to get A3 is equal to 60,000 1.005 to the cubed, so to the power of 3, minus 800 1.005 squared minus 800 1.005 minus 800. Okay? So then, if I just kind of abbreviate this to AN, that means we're going to get that AN is equal to 60,000 outside of 1.005 to the power of N. And the reason why is because when we had A3, it's to the power of 3. When we had A2, it's to the power of 2. And if you think about it, A1 was to the power of 1 there. So it's 1.005 to the power of N minus 800 outside of 1.005 to the power of n minus 1. I hope you can understand that using the same sort of relation we did here. So when it was A3, the first 800 term was 1.005 to the power of 2. So 1 less than kind of the number that we see here. So n minus 1 minus 800, 1.005, n minus 2. And it keeps going down, minus dot, dot, dot. And we can just say it ends at a final minus 800. Okay. And if we're kind of being smart about it, we can collect like terms. So we can collect the minus 800 here. And then it just becomes 1.05 to the n minus 1 plus 1.005 plus 1.005 to the power of n minus 2 plus all the way to 1. Okay. Now we want to know what the amount is after the 94th withdrawal, which is A94. So applying that technique, it's 60,000, 1.005 to the power of 94 minus 800 outside of 1.05 to the power of 93 plus 1.005 to the 92. Plus all the way to 1. Now, what you need to notice is that this term here is a GP, is a geometric progression. And so we can use the formula for the sum of the GP to obtain that whole section there. So 1.005 to the power of 94 minus 800. Now, GP. So our starting term, if you want to think about it, is we go from back to front. So this is going to be 1 plus 1.005 plus 1.005 squared, and so on and so forth. And so if you think about the sum of the GP, it's R, which is 1.005, to the power of n, which is the number of terms that we have, which is going to be 94 terms, minus 1, on R minus 1, which is R 1.005 minus 1. So that gets you 0.005. Now, if you just plug all this into your calculator, you end up with 187 and 85 cents. Okay? I hope that makes sense there. And that's pretty much this question here. Now, question 27 got a lot of people talking. A lot of people seem to find this question a little bit difficult, but when you actually take things step by step, it actually isn't a very difficult question. I think where a lot of students got carried away in the actual HSC exam was just the fact that it's super long and there's just a lot of information thrown at you, but when you know what information to kind of look for and what to digest, it's actually very, very simple. So let's just briefly go through it. So we've got a cricket that is chirping, and a scientist wants to explore the relationship between the temperature and the number of cricket chirps that's heard in some sort of 15-second interval. So once a day for 20 days, the scientists collect their data, and the 20 data points were collected and kind of mapped using this box plot. So we can see the median is at 22, our minimum's at 13, and our maximum was at 27. Okay? So the mean temperature was 0.525 below the median temperature. So keep in mind this is a temperature scale. So we're saying the mean was 0.525 below the median. We're saying a total of 684 chirps was counted when collecting the 20 data points. And we're fitting a least squares regression line where x is the temperature in degrees Celsius and y is the number of chirps. So we get this regression line that we fit. Now, the least squares regression line passes through this point here, x bar, y bar, where x bar is the sample mean of the temperature data and y bar is the sample mean of the chirp data. The question says, calculate the number of chirps expected in a 15-second interval when the temperature is 19 degrees Celsius. Give your answer to the nearest whole number. So it's saying using this line that we saw here, this equation, so y being the number of chirps, it's saying when x equals 19 degrees, what is y? Okay? And what we actually need to do is sub in 19 and find out y. But the only thing that's stopping us from doing that is that we just don't know what b is, which is the slope of the regression line. But to find b, we're going to need to kind of sub in a point, right, which we know goes through the line, and work through it that way. So x bar and y bar. So x bar is the sample mean of the temperature data. Now we've got that through this information here. Let's read it again. The mean temperature in the data set is 0.525 below the median temperature. So the median was 22, right? So that means x bar is 22 minus 0.525, right? Pretty simple. And if we calculate that, we're going to get 21.475. Now, y bar, which is the sample mean of the chirp data. Now, to figure that out, we're going to use this information here, which says the total of 684 chirps was counted when collecting the 20 data points. So if a total of 684 chirps are counted in 20 crickets, then the mean, or the average chirp per cricket, is the 684 divided by 20, right? And then we just get 34.2, right? And from here, it's just a matter of kind of just substituting the equation. So we know that the equation is y equals minus 10.6063 plus bx. Then when we substitute y bar x bar, so sub x bar y bar, then we're going to get 34.2 equals minus 10.6063 plus b times 21.475. And I'm going to just skip the algebra here and just say b is going to be equal to 2.0864 whatever, right? And then it's pretty simple, because now we've got our equation and we just say when x equals 19, then we know y is going to be equal to minus 10.6063 plus 2.0864 whatever times 19. And then to find our y, we just sub everything in and plug it in our calculator, and we get 29.036 chirps, or to the nearest whole number is 29 chirps. So, like I said before, not a very difficult question at all, but where a lot of students got carried away was just the fact that there's just a lot of fluff in setting it up for the question, but the only important information were these 2 dot points there. So question 28 says, in a particular country, the hourly rate of pay for adults who work is normally distributed with a mean of 25 and a standard deviation of 5. 2 adults who both work are chosen at random. Find the probability that at least one of them earns between that amount. So if we consider our rules of probability, the probability of like at least one is equal to 1 minus the probability of none. So now we're trying to find the probability that none of the 2 adults earn between 15 and 20. So now let's just start with, very simply, what is the probability that a single adult earns between 15 and 30 per hour? So we know that this is a normal distribution with mean of 25, standard deviation of 5. So if we kind of consider like a little bell curve, our mean is here, 25, and our shape is kind of like this, like a little bell. And one standard deviation is 30, because if you go 25 plus 5, we get 30, and that's one standard deviation. And the 15 lies 2 standard deviations behind. Okay, so this is z, if you like to think of it as minus 2, and z equals 1. So if we kind of use the 68, 95, 99.7 rule, we can find an approximate percentage for the amount of people that lie within that bracket. And well, the easiest way I can think of it is if you consider the first standard deviation, so between -1 to 1, that's equal to 68%, which means half of that, right, from 0 to +1 is 34%, right? And then if you consider the same thing but for 2 standard deviations, so -2 to 2, that's 95%. But if we just take from -2 to 0, that's equal to half of 95, which is going to be 47.5%. And now you've kind of got your two regions from -2 to 0 to 0 to +1. And so if you kind of take those two regions, so the probability of 15 to 30 is now then just going to be 34% plus 47.5%, which gets you 81.5%. Okay, so that's the probability that one adult is going to earn between that much. So the probability that they don't is going to be probability that they essentially earn less than 15 or more than 30 is going to be 100% minus 81.5%. Okay, and that simplifies to 18.5%. And then coming back up here, probability that at least one is 1 minus the probability of none. And that probability of none is 18.5% squared, because both of them need to kind of not earn that much. And then from there, it's 0.965775. Okay, so it's quite likely that at least one of them are going to be earning between $50 and $30. The next question says the number of adults who work is equal to 3 times the number of adults who do not work. One adult is chosen at random. Find the probability that the chosen adult works and earns more than $25 per hour. So the probability that someone is going to be earning more than $25 per hour should be pretty simple, because that's going to follow your normal distribution, and because 25 is the mean, then it's just equal to half, because that's your mean. So going above the mean or below the mean is both sort of like a 50-50 chance, we consider it. So then it's just a matter of what's the probability that the adult works. And so we need to use this information here. So we know that the number of adults who work is equal to 3 times that number of adults who do not work. So that means if I have 4 people, right, 3 work and 1 doesn't, which means the probability that someone actually works, so probability that of a worker is 3 in 4. So therefore the probability that they work and that their salary is greater than $25 is going to be 3 on 4 multiplied by half, and that just gets you 3 on 8. Okay, pretty simple. Question 29 says the diagram shows the graph of y equals c ln x, and we need to show that the equation of the tangent to this line at x equals p, where p is greater than 0, is given by this equation. So this is pretty standard sort of maths, but there's just a lot of algebra involved. No numbers, which can kind of make things a little bit harder. But we know that the line is y equals c ln x. we want to find the gradient of this, we want to derive it to find like the gradient function, so dy dx. Now c ln x goes to c on x, because ln x, when you derive that goes to 1 on x. And then at x equals p, dy dx is equal to c on p, so therefore the gradient of the tangent is equal to c on p. Okay, and then from there, we say at x equals p, y is going to be c ln p. That's just simply by subbing it into the formula. And then if we think about how to find the equation of a line using the gradient and a point, it's going to be y minus y1 equals m outside of x minus x1. And so our x1 and y1 are going to be p and c ln p. And our gradient, our m, is going to be c on p. So that means y minus c ln p equals c on p outside of x minus p. Now, we need y to be the subject of our equation. So y equals, if I plus c ln p over and then multiply everything here, so I get c on px. So c on p times x is c on px. And then c on p times negative p gets you negative c. And then I just add over that c ln p there. And that's exactly equal to what we're required to find. The next question says, find the value of c such that the tangent from part A has a gradient of 1 and passes through the origin. Okay, so we need the gradient m to be equal to 1, and it needs to pass through the origin, which means, so our gradient was c on p, so c on p needs to equal 1, and that implies that c equals p. So if c equals p, and we know that it needs to pass through the origin, then we kind of take our line and set x equals 0 and y equals 0. So if x equals 0 and y equals 0, then what that means is we have 0 equals c on p times 0 minus c plus c ln p. Okay, so that means we've got 0 equals minus c plus c ln p, which means c ln p is equal to c, which means ln p is equal to 1. Actually, my bad, sorry, we can't divide by c because c might be equal to 0. So we subtract c, so then c ln p minus c equals 0. And then we factorize, so c outside of ln p minus 1 equals 0. So we get two things. We get either c equals 0 or ln p equals 1, which implies that p is equal to e. Okay? But if c equals p and p, they tell us, is greater than 0, then we rule out the option that c is greater, that c is equal to 0. So that means we're only left with p being equal to e. And therefore c is equal to e because c is equal to p. Okay, hope that makes sense. So now we get on to the second last question. And the second last question says, the diagram shows two parabolas, y equals 4x minus x squared and y equals ax squared, where a is greater than 0. The two parabolas intersect at O and A. We need to show that the x coordinate of A is 4 on A plus 1. So this is pretty simple. All we need to do is kind of equate the two equations and solve for x. So that means we're going to say ax squared is equal to 4x minus x squared. And then we're going to bring everything over to one side. So we're going to say ax squared plus x squared minus 4x equals 0. I can factorize everything by x. So I get x outside of ax plus 1 minus 4. Sorry, plus x, my bad, equals 0. And then I can factorize a little bit further here. So I can say x outside of xa plus 1 minus 4 equals 0. So that means I'm going to get two solutions. The first one is going to be that x equals 0. And the next one is going to be that x outside of a plus 1 is equal to 4, or x is equal to 4 on a plus 1. Okay? And we know that they meet at the origin and some other point, which means that x equals 0 is relating to the origin. So that means since a has x greater than 0, we know that x is equal to 4 on a plus 1. Okay? The next question, the second part rather of this question says, find the value of a such that the shaded area is 16 on 3. So the shaded area, we're going to need to use top minus bottom technique. So as we can see here, we've got a parabola here, which in this shaded region, the parabola is on top, and the concave down parabola rather is on top. So this equation here, 4x minus x squared, and then y equals ax squared is on the bottom. And that's going to be from 0 to a. So we say the area is equal to 0 to 4 on a plus 1 of our top graph, 4x minus x squared, minus the bottom graph, which is ax squared. Okay? But we know our area is equal to 16 on 3, so let's plug that in. And let's now integrate. Let's just collect like terms. That's probably going to be easiest. 4x minus x squared outside of a plus 1 dx. And now we can integrate. Okay, so we're going to get 16 on 3 is equal to 2x squared. And that's because we go 4x squared on 2, which goes to 2x squared, minus a plus 1 on 3x cubed. Okay? And that's because x squared goes to x cubed, and then we divide by the 3. Now then plugging in 4 on a plus 1 and 0 into this equation. Now when we plug in 0, those terms are just going to cancel out, so we can just worry about the 4 on a plus 1. So that means 16 on 3 is equal to 2 outside of 4 on a plus 1 squared minus a plus 1 on 3 outside of 4 on a plus 1 cubed. And that's going to be equal to 16 on 3. Now, 4 squared gets you 16 times 2 gets you 32. And I'm going to just for now leave it as a plus 1 squared on the bottom. Now over here, we've got 4 cubed, which is equal to 64 over 3. Now if you consider a plus 1 cubed, but we've got an a plus 1 on the top, so those cancel out, which leaves us a plus 1 squared on the bottom. Right? So on the bottom, because of this cubed here, we're going to have a plus 1 cubed, but because we've got an a plus 1 on the top, it brings the power down on the bottom by 1. So that's what we've got there. And then what we can do here is these are like terms now. So what it becomes is 16 on 3. Now if I multiply up here by if I multiply the top and bottom of this fraction by 3, I get the top being 96 on 3 a plus 1 squared minus 64 on 3 a plus 1 squared. And then 96 minus 64 gets you 32. So we got 16 on 3 equals 32 on 3 outside of a plus 1 squared. And then if we bring a plus 1 squared up here and then divide by 16 on 3, we're going to get a plus 1 squared is equal to 2. Okay? And that's because when we multiply the 3 up here, it cancels with the 3 on the bottom. And then 16 on the bottom gets you 32 over 16, which is 2. That means a plus 1 is equal to plus or minus root 2, that means a is negative 1 plus or minus root 2. But if we observe the graph, and it even tells us actually as well that a is greater than 0, which means we can only accept the positive case. So since a is greater than 0, a is equal to -1 plus root 2. And that's our answer over there. Simple as that. We now get to the final question of the paper, which is probably the most, not necessarily difficult, but definitely the most time consuming and takes a lot of thought and consideration. But if you are very familiar with trigonometric graphs, then this question really isn't difficult at all. So the population of mice on an isolated island can be modeled by this function here, where t is the time in weeks from 0 to 52, and the population of mice reaches a maximum of 35,000 when t equals 13. So that's saying at this point here, that's when t equals 13, and a minimum of 5,000, so 5,000, which was right here, when t equals 39. The graph of mt is shown. So the question then says, what are the values of a and b? So a and b, well, what we need to know is that, just a few terms, is that a is our amplitude of the graph, and b is kind of our center line. So what we need to understand is that if b is our center line, then where is our graph kind of centered around? And we can see it's centered around this point. And how we calculate that is, well, if we take our maximum and our minimum, it's always going to be in the middle of those 2 points. So, or in other words, the average. So if I take, so b, and that's equal to 35,000 plus 5,000 divided by 2, because it's the average of those two numbers, which gets you with 20,000. Okay? And then to find the amplitude is kind of defined as how far out the maximum and minimum are from the center. So if we now know that this is 20,000, then how far up or down is our max and min? And we can see it's a difference of 15,000. Okay? So that's equal to our amplitude. Now, if you wanted to calculate that, what you can do is subtract the two numbers and average that. So if you go 35,000 minus 5,000, that gets you 30,000, and then half that gets you the 15 that we need. So we move on to part B of this question, which says on the same island, the population of cats can be modeled by the function ct equals all that. So it says then consider the graph of mt and the graph of ct, find the values of t for 0 to 52, for which both populations are going to be increasing. So in this case, what we need to do is, well, consider the graphs, because the alternative method would be to derive them and find when that is going to be, find when the derivative is going to be greater than 0, because that's going to be when it's increasing. But that's going to be pretty complex because this is a very complex trig formula. So if we are confident with how to graph trig functions, then that is definitely the way that we're going to go. So the first thing that we should do is find the period. Okay, so the period is equal to 2 pi on b, which is pi on 26. So pi on 26, and you get a period of 52. Okay, and then what we need to know is that, well, this 120 here is our center line, as we had in part A, and 80 is going to be our amplitude. So if I just do a rough one here, we have a 120, and then our amplitude is going to be up 80 from the 120, which is going to be 200, or down 120 by 80, which is going to be 40. Okay, and then this is a cos curve, which means we start at the top and go down. Okay, but what we have is a negative in front of the whole function, which means we flip it. And so that means we start from the bottom and go up. Okay, like so, like that dotted line. And then finally, one important thing is this minus 10 inside, like the bracket next to the t. And that means we shift everything right by 10 units. Okay, so if we shift everything right by 10 units, effectively what we can think about is that we start at 10 units. Okay, we're going to start our graph at 10 seconds. So if we try and get things working here, right? let's say we have that. 0 here, let's say 120 is in the middle there. We go up to 200 up here, and we go down to 40 about there. So if the best way to approach this is, because we're translating it by 10 units to the right, then at 10, let's start at our starting point, which is going to be 40, because remember, we start from the bottom. And if our period is 52, right? If our period is 52, then that means half of 52, which is 26, is when we're going to hit our peak, right? But because we're starting at 10 units, then instead of 26, it's then going to be 32. So if we start to draw the cos curve, it can look like that, where this here is going to be equal to 36, where it should normally be, where the difference between the trough and the peak is 26 units, which is half your period. And that makes sense, considering, yeah, everything's been translated by 10 units. So instead of 26, it's now 36. Okay. And then before 10, we kind of go up like that. And then after 36 to get to 52, well, we move down. And if you consider the only parts that we're increasing, well, that's from 10 to 36, right? So CT increases from 10 to T to 36, right? But if you consider the original graph, right, over here, and consider where it's increasing, that's from 0 to 13 and 39 to 52, okay? So MT increases from, it was 0 to 13 and from 39 to 52. So now the question says, where both populations, so therefore both populations increase from 10 to 13 seconds, because you need to consider when kind of these regions all intersect, and that only happens from 10 to 13 seconds. Then we move to the final question. Find the rate of change of the mice population when the cat population reaches a maximum. Okay? So when the cat population reaches a maximum, if we think about it, the cat population reaches a maximum. This is the cat graph. When does it reach a maximum? It reaches a maximum at 36 degrees. So let's say that cat population reaches a max at let's say T equals 36. Okay. So traditionally, whenever we see the word maximum, we want to kind of, derive and then let the derivative equal to 0 and, so on and so forth. But in this specific case, because we have the graphs, we can clearly see that we have a maximum. Okay. And that happens at 36 seconds, which we concluded. And then, so find now the rate of change of mice population. So if we consider our original graph of mice population, it was MT is equal to, what is it? It was 15,000 sine pi on 26 T plus 20,000. Okay, and then all we need to do is derive this, so m dash t, and that gets us pi on 26 times 15,000 cos pi on 26t, and then we sub in 36. So at t equals 36, we sub it in, ensure that our answer is in radians, and we get m dash t, ensure that our calculator is in radians, and then we end up getting minus 642.7, and therefore we can conclude mice population decreases because of that negative, so decreases at 643 mice. And now T is weekly, so per week. And that's that. That is all the questions in section 2 of the 2020 Advanced HSC paper. Hope that you found this useful. Please, in the comments, if you have any questions, do reach out and hopefully I can get back to you.